Hello, hello, and welcome to this live product launch from TecQuipment. My name is Dion Knowles. I'm the marketing manager here at TecQuipment, and today we are taking you through the Advanced HVAC and R Trainer. I'm also joined by Javi Martinez. Javi, are you there?
Hello, everybody.
Hello, great to see you. Thanks for joining us, Javi. Javi is our HVAC and our specialist, our #1 specialist at TecQuipment, and he's the man behind the development of this new product that we've got with our team at the headquarters in Long Eaton. He's going to be joining me today to talk about some of the HVAC and R theory, as well as introducing you to the Advanced HVAC and R Trainer. It's great to see so many people joining us live today. Do put comments in the comment box. Let us know where you're from. I can see a few people up there already. Great to see you, Benedict. Hi, lovely to see you. And Hendry. And so keep popping your names in there. It's great to know everybody's out there. So what we're going to be doing, stay with me, because we're going to be reviewing the Advanced HVAC and R Trainer. We're going to be looking at all the different features and functions. Then Javi's going to talk about theory, and you can ask your questions at any time in the chat box. Then we'll look at how this sits within the whole of the environmental control range from TecQuipment. We'll talk about when you can get your hands on one of these, when you can get one in your lab. And at the very end, I'm going to be telling you about another product that we have coming up soon in the renewables range. So stick with me throughout the course of this live session to go through all of that information. Okay, so Sambit, a quick shout out to you as well for joining us. Fantastic to see you here with us today. So let's get started now. Welcome to the launch of the Advanced HVAC and R Trainer. My name is Dion Knowles. I'm the marketing manager at TecQuipment. Today we're going to be telling you more about the new piece of teaching and research equipment for understanding heating, ventilation, air conditioning and refrigeration, whether that's both in a single individual psychrometric process, but also in a combined psychrometric process. And you can look at things like vapor compression, refrigeration cycle, the use of pressure enthalpy charts, and I mentioned also research as well. Before we move on, I'm going to jump to a video segment that we recorded a couple of weeks in the TecQuipment headquarters that walks you around the product. It allows you to look at different elements. We explain all the different processes involved. We're going to come back after that, so stick with us because we're going to be coming back to talk about HVAC theory. We're going to be talking about things like how we can mimic different environments, the process of adiabatic cooling, the research capabilities that are with these, the ancillaries, which are mentioned in the video, but we'll come back to them and cover them in more detail. If you're watching this on demand, don't forget you can put your questions in the comment box below. And if you're watching it live, you can put it in the chat box as well. So let's jump straight to some materials that we prepared earlier. You to the Advanced HVAC and R Trainer. This is part of the environmental control range of practical teaching equipment from TecQuipment. If you want to teach or are studying heating, ventilation, air conditioning and refrigeration, HVAC and R systems at an advanced level, this piece of teaching equipment could be what you need. The beauty of this entire system apparatus is that it allows you to both analyse individual and combined psychrometric processes commonly used in air conditioning, plus study concepts such as the vapor compression refrigeration cycle, including the use of pressure enthalpy charts. Before we jump into the technicalities, for those watching that are pondering why HVAC and R is such an issue, let me bring in a little context. Rising environmental concerns and increasing worldwide energy demands are driving future engineers to understand air conditioning systems and how to make these more energy efficient in order to reduce the environmental footprint and save money. air conditioning involves full control over temperature, humidity, air quality within the conditioned space. Broadly speaking, air conditioning systems fall into two categories. These are human comfort and process air conditioning systems. 4 air processes are required in order to control the environment. These are heating, cooling, humidification and dehumidification. Now let's get back to the Advanced HVAC R Trainer. There are 3 main elements to this apparatus: the control panel up here and 2 units for understanding different types of HVAC and R systems, the air handling unit and the water chiller. A recirculating duct and an environmental control chamber that you can see here can each be purchased as extra ancillaries to extend the experimentational options. For HVAC, we have the air handling unit, which conditions the air using 1 or more different processes. It allows you to analyze psychrometric processes commonly used in air conditioning, both individually or as a combined system. By working step by step through the experiments in the user guide, students can learn about PID-controlled electric heating, isothermal humidification, cooling, adiabatic humidification, adiabatic mixing of air streams, and the concept of human comfort. For refrigeration, we have the water chiller that enables you to delve deeper into the topic for a full understanding of the vapor compression refrigeration cycle. While running experiments outlined in the user guide, you can plot the psychrometric cycle in real time, calculate and plot the data for pH diagram, learn about superheat and subcooling diagrams, as well as understand the refrigerant mass for flow rate and COP. This is an advanced piece of apparatus, and with this in mind has versatile data acquisition integrated, i.e. VDAS is on board. That means all the charting can be done for you within the software and the results can automatically be recorded. With the overview done, now it's time to look at the different elements more closely. At the core, the base unit includes the control panel. This has all the control functionality for changing the airflow velocity, temperature, water flow rates, and has the VDAS on board included as well. Onto the air handling unit, which attaches to the base unit. Starting over here, the air enters the unit through a grill with a filter and dampener in the air intake control area. Just a little along is the variable speed fan that can move at a maximum of 1200 cubic meters per hour. Further along, there is a PID controlled electric heater and then an electric immersion heater for steam humidification. There's a water heater to heat the heat exchanger that draws the water using a pump from the water in the tank with the flow measured by a flow meter. After this section is the air washer humidifier that is connected to a pump that pulls water from the tank. Then there is another PID controlled electric heater and finally an outlet for the air. Moving on to the water chiller for understanding refrigeration. The water in the tank here is controlled by the evaporator coil using R134 refrigerant. The water can then be used by the water to air heat exchanger inside the air handling unit to cool down the air. To allow students to analyse the heat transfer across the water to air heat exchanger under different loads, there's a water flow meter and a pair of thermocouples along with a variable flow pump provided. The additional recirculating duct ancillary allows students to investigate adiabatic mixing of air systems at different mass flow rates, as well as expanding the boundaries of physical and thermodynamic properties of gas-vapor mixtures. The last main section of hardware is another ancillary, the environmental control chamber. This takes the student experience to another level, allowing them to physically experience the changes in temperature and humidity. Like I'm doing now, as you can see, a student can stand within this 2 cubic meter chamber that mimics a room. You can then assess the comfort level and compare this with industry-specific calculations, such as the predicted mean vote and percentage of people dissatisfied. You can see that all the elements are fitted with lights and windows, allowing students to clearly see the components of each air process. And fitted at the end of each air process are temperature and humidity sensors. There are also two airflow sensors within the main unit and an additional one within the recirculating duct ancillary for mass balance. These are movable and can be placed in pockets that are positioned at the different air processes. Data acquisition is all done using TecQuipment's versatile data acquisition system, also known as VDAS. This consists of the hardware, which is VDAS on board in this case, and the software, which is free to download from TecQuipment's website. I'm just going to touch here on some of the specific charting capabilities now. The pressure enthalpy and the psychrometric charts can be created easily by clicking on the respective icons on the toolbar. Within each of these, you can adjust variables by checking or unchecking boxes to show items. For the pressure enthalpy chart, you can turn on and off items including constant entropy, temperature, specific volume and quality. Likewise, on the psychrometric chart, you can adjust wet bulb temperature, constant specific volume, specific enthalpy and constant relative humidity. For more information about the Advanced HVAC R Trainer and other standalone experiments in the environmental control range from TecQuipment, click on the links. And if you like this video, don't forget to give it a thumbs up. Thank you for watching. There we go. I hope you found that informative. Now we're going to reiterate a few of those points, explain some of those. We've had some questions in the meantime. Let me go back to my questions dashboard here. So Javi, are you there? I need to allow you to speak again. Sorry, Javi. I put you momentarily on mute. I'll let you unmute yourself and appear. So Javi will magically appear on our screens in a moment.
Hello.
Hello, Javi. You're
Hello.
there.
Hello again.
Okay. Right, Javi. So the questions are here: is vapor absorption refrigeration available?
No, it is not.
Okay.
We've got vapor compression because the compressor that we're using is hermetic reciprocating compression, and there is not absorption process.
Okay, brilliant. Thank you for the clarification on that. Now, we've also had another question about PID controlling of the temperature and humidity in the environmental control chamber and the recirculating duct. Here are those two ancillaries that we talk about. Can you PID control the temperature and humidity in those?
Sorry, yes, we can PID control the temperature, and we cannot PID control the humidity. We can control the humidity, but not via a PID controller. The PID controllers, they control the temperature at both the heating process and the reheating.
Okay, brilliant. I think one thing that we really want to emphasize here is not making everything too easy. This is a piece of teaching apparatus. We have to get students to work through the process, don't we? And that's something that you've certainly always taken into account when we're designing our teaching apparatus. But Javi, you've been particularly mindful of that, haven't you, in the creation of this particular piece of apparatus?
Indeed, and we've got two different ways of controlling humidity. One is isothermal humidification via the steamer, which is
that's this bit here, isn't it?
No, that's the red box.
Oh, okay, the red box. Apologies.
Isothermal humidification, and the other one is adiabatic cooling, which is injecting water. That's the one, yes, injecting water into the airstream. So yeah, we've got two ways of controlling humidity, but the humidity is not controlled via PID. However, the heating, it is controlled via PID at both stages, the heating process and the reheating.
Okay, and these are all the PID controllers.
And these are the PID controllers, correct.
Zoom in and have a look at those there. You can't see it particularly well on that picture. But if you go on the data on the website, look at the products. We've got all the data sheets on there. We've got more detailed pictures, so you can delve into those some more. Okay, so let's head back now. Now, Javi, another thing is with this piece of apparatus, not mentioned in the video, is the ability to mimic different environments. Why is this so important? Could you put this in a bit more context for us?
Well, basically, this apparatus, we need to assume that it is going to be installed in a lab, in a university lab. And that lab is going to be, the air in the lab is going to be normally conditioned already. So it's going to be at human comfort. So what happens, for example, if we want to test the different devices, the performance under different climatic conditions? Let's say that we want to study air when it's hot and dry, like for example, in the Middle East, let's say Qatar, or in a hot and humid country like Malaysia, right? What we can do is uncondition the air, create these environmental conditions, and then recondition the air. And
Right.
that
Okay.
offers great capabilities. Let's say, for example, that we've got a hot and dry air, air that is already conditioned in the lab. You will expect temperatures normally between 20 to 22 degrees and relative humidities between 50 and 70%. If we switch on the preheater, we are going to achieve temperatures that are 30 to 35 degrees with relative humidities between 28, 29% to 30, 35%. So that is hot and dry.
Right.
Then we can cool down the air. In that case, we can increase the experiment range and increase also the research capabilities.
Okay, so you jumped to that point actually, research. What are the research capabilities with this particular trainer that we've got here today?
Well, one of the core things that we've got a very, very good and robust data acquisition. And obviously, once you've got the structured data, it's really up to the student imagination. What you want to do with it? Because we are monitoring all the variables at each stage of the process.
Right. Okay.
And
Okay.
we can go as down as monitoring the variable every half a second. In the test, there is no need to go down that much actually, especially knowing that HVAC systems, one of the easy things that they've got actually is they are not time critical.
Yeah.
So yeah, but yeah, monitoring every second is an option. And obviously after this, the students, they can analyze that data and drag their own conclusions. And really you can take it from very, very basic level and do very simple graphs to do research at PhD level and go into the nitty gritty of each thermodynamic process. So yeah, it provides great flexibility.
Okay, brilliant. And I mean, the look and the feel of this is very much like an industrial feel piece of equipment. And we have been quite mindful in terms of the selection of the components that match what's being used in industry as much as possible, so that it's very much of an authentic experience for students using whatever levels they might be using at, whether it's basic level or whether it's kind of PhD research level. Javi, we were talking about recently about the different relevant teaching courses and the fact that this is relevant for both mechanical engineering, environmental engineering, and the built environment. And I think you were telling us that if you were doing an environmental engineering course, and I believe you've got a master's, haven't you? I'm just going back to my notes now, in renewable energy and architecture. Would you see this kind of being in that kind of course? Where you start straight in and understand that's, this is the entry level for you. And in some courses, I guess in mechanical engineering, this is going to be advanced third year content.
Absolutely, yeah. It's got components, as you say, of mechanical engineering, but also renewables and energy efficiency. Because, for example, obviously we are here studying a water chiller, but a water chiller essentially, from a thermodynamic point of view, is very close to a heat pump. And heat pumps, as we know, they classify as renewable devices.
Yeah.
So yeah, we can study in that way, but also we can study mechanical engineering because, as you pointed out, it uses industry standard components. So this is actually what the students, they are going to see in the real market when they finish their degree and they are out there and they want to install, repair, or design a real system. That is what they have to do, basically.
Brilliant. Thank you for that. Sorry, Harvey, you've got something else to add on that point? Didn't mean to cut you short.
No, I just wanted to mention as well the built environment and basically in terms of energy efficiency, which is very important these days given the environmental concerns. And and this is also something that they can study, because you can process the air in different ways, and you can compare how efficient is one process of, let's say, cooling the air with the dry cooler or cooling the air with the adiabatic cooler. You can compare the efficiency between the two.
Right, brilliant. Fantastic. Good. Thank you, Javi. Now I've got a question here, and I'm going to zoom back to this picture to have a look at it. Can the temperature in the chamber be regulated? And I guess we were talking about chamber being the recirculating duct. Can you explain again how that's done?
Sorry, no, the temperature in the chamber, it is monitored but not controlled.
Oh, we're talking about the environmental control chamber. Yes, of course.
I'm guessing, yeah, the temperature is monitored, is not the controls, they are in the control panel. So yeah, you can control the temperature so you can reach a desirable temperature in the environmental chamber. You can do that, no problem. But there is not a thermostat inside the environmental chamber. But by no means, yes, you can have the temperature spot on control inside the environmental chamber, but it's done from the control panel and not from inside the environmental chamber. If
Brilliant.
That makes sense.
That makes total sense. So inside, you just get in the chamber, and having been inside the chamber, you go in there, and the whole idea is you're experiencing the humidity and the temperature. And outside, you might have a colleague or a fellow student who is controlling, or I guess you can set the controls and then climb inside the chamber and feel what it's like. Is that right, Javi?
Correct. Yes, and obviously one of the challenges is to get the chamber perfectly controlled.
Yeah. Okay.
And
yes. Well, and that's part of the learning experience. Brilliant. Well, thank you for that. Let's move on now. We're going to talk a bit about theory, but before that, I wondered if you could spend a moment talking about the adiabatic cooling, because this is something very unique to this piece of teaching equipment, and it's understanding the psychrometric process of adiabatic humidification. Javi, do tell us more about why this is important, why it's included in this particular trainer.
Well, it's one more method of controlling both temperature and humidity of the air. It tends to be fairly energy efficient because all that is required is water and a fan. Okay. And it works particularly well in hot and dry environments. And it's a pretty simple process as well. So basically, water is pumped through a high pressure misting nozzles, and you inject water into the airstream, and basically that water absorbs the enthalpy from the air absorbs the moisture from the water, and the air gets cooled and humidified at the same time. Okay. So, and one advantage as well is that we can perform the experiment either with water at room temperature or water that is chilled, because it's, the inlet is from the water tank. So the students, they can compare the difference between pumping chilled water or pumping water that is at the room temperature. And it's one more way of cooling down the air and or adding humidity to the air. If all you want to do is adding moisture to the air, you can just pump the water. The water is going to cool down the air stream as well as humidifying it. And that is why you've got further down the line a reheater, so you can bring the temperature up again in case you need it.
Great, thank you. Well, for those who are baffled by many of this terminology, what is a psychrometric chart, what is a pressure enthalpy, Javi is going to give us all a base level of knowledge now. So over to you, Javi. You should have control.
So yes, basically I wanted to expand a bit more about the apparatus capabilities, you know, and how important and how flexible it is. And you can see here that Dion already in the video, she's been explaining the different processes, you know, and if you have a look at the schematic here, you will see that it's got quite a lot of different electromechanical devices for the different air psychometrics. And it is quite important that we've got them in this order, because as we mentioned before, we can mimic different climates. It really doesn't matter if you are in Malaysia, you are in the UK, you are in Norway. You can mimic different climates and then check the performance of the different devices independently of where you are. So let's say, for example, that we want to mimic the weather that you will get in a hot and humid country. Yeah, let's assume that the air in the room is going to be conditioned. So we can switch on the electric heater, then that air is going to get hotter. Obviously, we need to add humidification, so we can switch on the immersion heater. And then at this point, we've got hot and humid air, which is what you will normally get in a country like, for example, Malaysia. And then we can cool down the air, and we can cool down the air via the dry cooler or the water to air heat exchanger or the air washer humidifier. And we can control, we can monitor and control the process in different way. And the students, they can compare different approaches and how energy efficient these approaches are. And at the end of the day, it's all about experimentation and understanding the thermodynamics behind the different systems. So let's go to the basic. If I can get the there it is. Sorry about that. So, for example, this is one key learning outcome, yeah, for the student to understand psychometric charts, correct? So let's say that we are with students that first or second year student, and they are learning how to use psychometric charts, and they're learning about the individual psychometric processes, right? So okay, that's fair enough. So they can use this this system to learn at that level, but you can take it further, and then you can start doing more serious research. If I can get to the next slide, like that. For example, once they've learned how a psychometric chart works, they can take it to the next level. For example, this graph here on the top left looks like someone is got a highlighter and is been writing over the psychometric chart, but the reality is that that particular graph shows about just over 7 million psychometric processes, right? So that is showing part of the machine boundaries for that particular experiment that involved multiple psychometric processes. So
wow, that's 7 million. That's quite astounding when you put it in numbers like that.
That is quite a lot. So as opposed to, for example, this graph here on the top right hand side that is showing 1, 2, 3, 4 psychometric processes, right? So which level you want to pitch it is really up to you. You can really, the great flexibility. More challenging graph, kernel density estimation. Comparing, for example, this one here in the middle, the heat transfer rate for the water and for the air. Bear in mind that this box in the middle is dragging water from the water tank to the air heat exchanger. So we can compare the heat transfer on the air and the heat transfer in the water and put it in a frequency distribution graph. We could plot the losses through the system, or box and whisker plots for the, in this case, showing the temperature. So really it's up to the student imagination and the teacher at the level they want to pitch it, because obviously first year students, they are more likely to focus on graphs, simple graphs like that, simple theory, while other more advanced students, third, fourth year, they can go into something that is more challenging. And sorry, I've lost now.
Okay. We are back. You're back. We had a Zoom technical glitch, but we have returned once more. Let me share my screen again. I think we're on screen share. Let's go with that one. There you go. Now, last moment, I asked you what you were talking about, air and water heat transfer, and I asked you what kernel density was. I don't know whether you heard that, Javi, and I don't know whether anyone else did either.
It's probability distribution, basically, is how many times, in this case, for example, let's have a look at the temperature and the relative humidity. Yeah, the temperature is the red and the relative humidity is the blue. So in this particular experiment that it was running for time in seconds, 150,000 seconds, you know, the relative humidity, as you can see, it was around 70% most of the time, yeah, and it was about 60% for quite a bit as well, dropping down as nearly as 15% by using the heater and the reheater and recirculating the air at the same time. So really that expands the machine boundaries quite a lot, you know, allowing to do also research in non-human comfort areas, some of them obviously, because the machine is primarily designed for human comfort, right? So the electromechanical devices that it uses are primarily for human comfort, but some other industrial processes, like for example, vegetable drying, are possible to study. You could dry, let's put it in this way, you could dry vegetables in that environmental chamber.
All right. Okay, brilliant. I'll let you move on now then.
Okay, so this is, for example, in terms of the psychometrics, you can take it at any level that you like. And if I can get to the next slide.
I need to give you control back because of Zoom. There you go.
And let's see.
I'll tell you what, I'll skip you on. It's a bit quicker when I do it. There you go.
There you are. This is, for example, another crucial, very important piece of understanding for refrigeration engineers, yeah, the pH diagram, pressure enthalpy. So you can pitch it at basic level, understanding the thermodynamics behind the different processes, superheating, subcooling, latent heat, isentropic compression, and then again, you can take it to the different level. For example, same as the psychometric chart, the pH diagram is also plotted in real time through VIDAS. So the students, they got access to this, the students, they got access to the degrees of subcooling and superheat, right? So that's one level, is basic level for everybody, but then again, they can go into the nitty-gritty of the thermodynamics. Like, for example, this graph here, they can see the red line. It's quite important. We've got a power meter. That power meter is measuring the electrical consumption of the compressor. And it turns out that we also have one key piece of equipment, which is the refrigeration flow meter. So with the refrigeration flow meter, we can also calculate the theoretical power. And as you can see, it's doing this blue lining here, which is quite interesting. So the two are matching, but there is quite a lot of science behind that graph. And why is that happening? That can be object of research for a PhD student, for example. Same as this graph here. This 3D graph is showing the relation between the evaporating temperature, the condensing temperature, and the COP. Right? And that is more advanced. So you will normally see students on first, second year focusing on, for example, the pH diagram, simple COP graphs, the relation between the temperature and pressure in the system, and then you can move on to PhD students or master's degree students that they are getting into the nitty-gritty of the actual system. So basically, at the end of the day, the apparatus provides great flexibility and great research capabilities thanks to the robust data acquisition system. Once you've got the data, you've got pretty much everything you need to analyze the system and check the performance thoroughly at pretty much any level that you want to.
I think it's important to emphasize at this point that this piece of equipment, because it's got VDAS on board, and any product that has that is VDAS enabled, i.e. either has it integrated into the piece of apparatus, or you can have a VDAS hardware unit that works with the apparatus, you can use it with VDAS eLab. So if you are dealing with the challenges of blended learning, remote learning, combining, whatever your situation is right now, in terms of allowing students in the lab or not, or in the institution, you can use it with VDAS eLab, and that's the remote learning engagement software that you can get, so that students can actually work, analyze the data, gather the data remotely from their home office, wherever they might be in the world, with somebody physically running the piece of equipment in the lab itself.
Yes, I also like to point out that the system is very, very robust, and to the extent that for people that work with data in the field, one key thing, or one of the things that we've got to do sometimes, is to do what is called data wrangling and data cleaning.
Okay.
And sometimes that is a bit of a pain, because...
Did you say data wrangling? What was that term?
Cleaning the data, because the data many times comes quite dirty. So before analyzing any data, you've got to clean it. But in this case, the system is very good and is very robust, and it's not missing not even a single line of data, despite the monitoring is 1 second or even less if you want to. So it's really, really an impressive piece of kit and very good data acquisition system.
Okay, and can you run the experiments for a long period of time? Can you just leave it on, and what measures have you got?
Yeah, you can. In fact, technically speaking, you can run this 24/7.
Okay, right, fantastic, good. Have you got any more on theory, or are we wrapped up for that? I think we might be.
I think that is it for the moment, unless people got some additional questions.
We've got no more questions right now.
No more questions, yeah.
It doesn't mean that we won't have any more questions before this time is up, so don't leave me yet. Just stay there. Okay, so thanks, Javi. Now we're going to talk about availability. You can tomorrow is the 1st of October. You can start getting quotes on that, and we will start accepting orders as well. With the lead times involved, we're looking at this being available from January next year. So if you're interested, you either contact your local TecQuipment sales representative, have a discussion with them, start the quoting process, or either contact us directly and we will help you through that process. Okay, so that pretty much rounds us up for a brief of the Advanced HVAC and R Trainer. There's lots of information on our website. There's data sheets in there. You can look at specific specs, power consumption requirements, space requirements, etc. To delve onto there to get those further details. Before we go, and while you're thinking of any questions before we leave, I want to tell you about a few things that we have got coming up. One of those things is our next new product. We're talking renewables this time, and we are talking in particular wind turbines. We'll be launching the wind turbine on the 28th of October, so do join us live on YouTube then. We've got a live events playlist on YouTube, so you might want to also subscribe to that live events playlist so you don't miss any of our product launches or other live events like the Drive Live with an Engineer series. If you're not familiar with this series, the idea is that every time we have a live interactive discussion with an engineer or somebody who has had engineering roles throughout the course of their career, and we'll be finding out more about their career journey, what their role involved, and we'll be introducing different people. So a few weeks ago, we had Charlotte Starkman. Charlotte was a petroleum engineer. She worked on the oil rigs, and she came about that from studying a degree in chemistry degree rather. Well, the next one we've got is really exciting. We have a 90-year-old World War II veteran mechanical engineer. He worked on World War II frigates, on torpedoes. Then he went into food production technology, and he worked in Australia and various other places as well. So Mike Wright will be joining us on the 21st of October. We've got more people. I'm talking to someone in the USA not long after this launch today. So we've got people from around the world, different disciplines in engineering, and these are for the students. So the students who aren't able to really get, who haven't got connections with people in engineering, who can't meet people at university because of the COVID limitations that we've got at the moment, they can go on to a whole playlist that we've got, and we're building on there, interviewing different engineers from different disciplines from around the world. So this is your last chance to ask questions before we, during the live session. It's not over though, because you can of course ask questions in the comment box below. We have got a general introduction video to the Advanced HVAC R, which you saw earlier. That's available on a separate video link if you want to just view that in isolation, and I'll be putting that link in the comment box below. That's it from myself, from Javi. Thank you so much for imparting your knowledge with us today.
Thanks to you.
Thank you everybody for joining us. Don't forget to join us again on the 21st of October as we meet Mike Wright, ask your questions, and join us for the wind turbine launch on the 28th of October. If you're interested in VDAS eLab, go and check that out as well. That's all about remote learning and engagement. I'll put the link in the chat box below. Thank you very much, everybody. We look forward to chatting to you next time, seeing you next time. Thank you and goodbye.